So we've looked at the anatomy of a hypothesis, the null and alternate hypothesis, and we've also looked a couple times at how strong evidence against a claim or for a claim can be, and how that's affected by our sample size. We're going to put that together here and finish the ideas of the hypothesis test, and then we'll go into the mechanics of it in the next video. So going back to our same example that we've been using all the way through, Jefferson College students are smarter than average, which of course you all just inherently know that. We don't need any evidence. So what is our claim? Our claim is that the average IQ is greater than 100, right? That's our alternate hypothesis. That's the thing we're hoping to show. And the null hypothesis is that the average is actually just equal to 100, right? Remember, the null is always that the average is equal to a number. The alternate, right? The null, and the alternate is always that it is greater than or less than or not equal to. And this is the one that we actually kind of try to show. And we're going to talk about not 95% confidence here. When we did our intervals, we talked about confidence level. Now we're going to talk about something similar, which is that we've got 0.05 doubt. Right, 95% confidence, that leaves 5% doubt, and we call that our p-value. Sorry, that's not our p-value. That would be related to our p-value. We're going to call that our significance level. All right, so I want to show at the 5% significance level, the 0.05 significance level, that the average for Jeffco IQ is higher than 100 as opposed to just being equal to 100. Now we saw last time, or 2 times ago, that if we took 25 people and the IQ on average was equal to 103, that's going to happen 16% of the time. Okay, that's our p-value, is if the null hypothesis is true, if our average actually is 100, then this result, 25 chosen at random, would have an average IQ of 103 or more, is only going to happen that often. That is more than our significance level. So this is not good enough. We're only allowing 5% doubt. We get 16% doubt here. So that's not good enough. So we would say we do not have enough evidence to reject the null hypothesis, right? Because even if the null hypothesis is true, this result is going to happen 16% of the time. That's not sufficient evidence to reject the null hypothesis. So we fail to reject the null hypothesis. I'm not going to write these words down because it takes too much time. You want to write that down. If our p-value, that's the p-value, is greater than our significance level, then we fail to reject the null hypothesis. If you remember, we then took a sample of 100, found the average IQ for that sample of 100 was 103. That only happened 0.023, or 2.3% of the time. So again, if that's true, if it's true that Jefferson College is average, then this is going to happen. A sample of 100 chosen at random from Jeffco would have an IQ of 103. That's only going to happen 2.3% of the time. Not very likely. There, our p-value is less than our significance level, which means we will, write this down, reject the null hypothesis in favor of the alternate hypothesis. Okay, so we want to show the alternate hypothesis in this case. If we get this kind of result that would only happen less of the time than our allowable doubt, our significance level, if the p-value comes out to be less than that, then we can say, no, this isn't true. This must be true. At least we're 95% sure of that. We've got 5% doubt, but we're going to reject the null hypothesis in favor of the alternate hypothesis because this was convincing evidence that that's not true and that is. And convincing meaning 95% confidence. Okay, now this is totally a statistics class thing. I've been informed by our psychology guy that nobody that does research actually uses this terminology. But if the p-value is less than our significance level, we reject the null hypothesis in favor of the alternate. If it's higher, then we fail to reject. So make sure you know how to say that, because that's going to be a question on the test. So write it down, put it in your notes, and then copy it into the computer when the time comes. Later.